Hello, welcome back, and in today's lesson we are going to look at the environment, and in this topic we are going to consider weather and climate. So we are going to look at the meaning of environment first, and then we'll look at the types of environment we have, and then also we are going to look at the concept of weather and the instruments we use for measuring some weather elements, as well as the meaning of elements of weather. And then we are going to look at the attributes and look at how we can make accurate measurements with some of these elements of weather. So before we start, if you take your mind back to social studies in the junior secondary school and in the primary school, we say that social studies is the study of man and his interaction with his environment. And then we looked at the environment of man, and in the environment of man, it's either the environment is physical or social. So in today's lesson, we are going to look at that environment and what really is this environment, or what can we say an environment is. So an environment can simply be seen as the surrounding in which we live, or you can simply put it as everything surrounding us or everything around us. So when we say environment is everything around us, we're actually talking about the internal and external conditions that affect the humans in the earth, that affect the plants, that affect everything concerning us. So in this scenario, when we talk about environment, we are talking about the biotic factors, and we are also talking about the abiotic factors. And biotic factors are actually living conditions of the environment, and biotic factors include things like plants, things like animals. And when we talk about the abiotic factors, we are talking about those non-living things around us that affect us on a daily basis. So we can as well see environment as the totality of surrounding conditions. Environment can be seen as the totality of surrounding conditions, or you can also put it as the total surrounding or medium of any organism in a particular area. So if you look around you, around your house, around your neighborhood, around your state, what you see around you is your environment. And we have two types of environment. We have the physical environment, and we have the social or the human environment. So in geography, we basically consider majorly the physical aspects of the environment. And if you look at your physical environment, we have features like relief, features like highlands and lowlands. We have features like valleys, we have mountains, waterfalls, we have man-made features too in our environment. So all these things, be it biotic or abiotic, or be it living or non-living, or man-made or natural, are actually what combines to make up what we call the environment. So let's look at the importance of our environment. Why is our environment important? Now, the first one is that our environment, provides water, and air for plants and animals. Like I previously said in the previous topics when we talked about the solar system, you see that the Earth is actually the only planet that supports living. And that is to say that the environment in planet Earth supports life by providing water and providing air for the biotic component of the environment. Also, the environment provides food for us, through what we call producers, where we have macro or microorganisms, getting food directly from the sunlight. So it's only possible in the environment where we can easily get food for both plants and also for both animals through the food chain. And the environment provides us with energy through things like food and gases or fuel. The environment also provides us with raw materials that we can use for industrial purposes, and medicinal substances that are needed by humans are also gotten from what? From the environment. You go to the pharmacy, you look at the drugs you buy, most of them are actually gotten from or sourced from the environment, you know. So the environment also acts as a primary support for us. If you look at man in the environment, you see that the environment actually provides man with a place to settle. That is, provides man with shelter, provides man with water, provides man with food and energy. So the environment is actually a primary source of support for man. That's to say that if man should go to other environments away from the earth, it will be very difficult for them to get this primary source of support because they are only found in the earth's environment. So let's look at more relevance of the environment. So the environment also serve as a good site for tourism and also a site for mineral resources. Now, if you look at the natural environment, you will discover that we have lots of amazing features that are natural around us that we can actually sightsee and have pleasure. And also most places or most regions of the world, they're actually blessed with lots of mineral resources that we can as well explore and utilize for the benefit of man. Also, our environment provides us with good sites for recreational activities, good sites for fishing, good sites for ports, especially places that are close to the ocean or the water body. And our environment also generates electricity for us, either through hydroelectric power or through the power of wind, or from any other source of energy like a bio form of energy or a thermal form of energy, or even a geothermal form of energy too. And also our environment provides employment opportunities for us. Take for instance the farmer, take for instance the lumberman, take for instance the fisherman. These people, they get what to do as a result of the resources being made available by the environment. And also the environment provides us with land that we can use for agricultural purposes, like mechanized farming, like subsistence farming, like nomadic farming and the rest. They are all made possible as a result of the environment. So let's look at weather. What is weather? Now, weather is simply the condition or the state of the atmosphere of a particular place at a particular period of time. Weather is the condition or the state of the atmosphere, at a particular place at a particular point in time. Or you can as well see weather as the atmospheric condition of a place at a very short period of time. And if you look at the layers of the external earth, we talked about the hydrosphere, we talked about the biosphere, we talked about the atmosphere. Now, the atmosphere is a place where we have different activities of weather and climate going on, and weather is actually experienced in the lower part of the atmosphere, which is the troposphere, And it is there where we have things like cloud formation, rainfall, and other elements of weather, taking place. So we use the word weather to describe the atmospheric condition at a particular time. That's why we have terminologies like sunny, like cloudy, like cold, like dusty, like humid. These words actually describe how the weather is at a certain period of time. Because one thing about the term weather is that it changes, with time. So let's look at what we call weather elements or elements of weather. Now, when we say elements of weather or weather elements, we are actually talking about the things that we need, to measure, or the things we need to observe in order to get a fair picture of what the weather of a place is. So anything we need to measure or we need to observe to describe the weather of a particular place is called the elements of weather. And we actually have 7 main elements of weather. They include things like rainfall, we have temperature, we have wind, atmospheric pressure, we have cloud, we have humidity, and we have sunshine. So let's go over to those weather elements. Now, these weather elements are actually measured with what we call weather records. Now, if you go to a meteorological station or in schools where they have these records, now these records are actually kept on a daily basis. Now, they are actually used to measure some of these elements that we have mentioned, like the amount of sunshine, like the amount of rainfall, the direction of wind and the speed of wind, and at the atmospheric pressure of that particular place. And we, in the weather record, we have what we call the weather record sheet. Now, in every school where weather records are being kept, the weather recording sheet contains the name of the school, or even if it's not a school, it contains the name of the station where the recording is being kept. Now, we have the month of recording, we have the time of recording, and we have the table containing the values of what is being recorded with the instruments we use to measure those elements of weather. So this is a typical example of how a weather recording sheet looks like. So we look at the next the first element of weather, which is called rainfall. Rainfall is a type of precipitation that occurs when water vapor in the clouds finally falls after acquiescing and staying up there for a very long period of time. So when we have the cloud not being able to hold this vapor for a long time, or condensed droplets, it's finally falls down as rain. And we make use of an instrument called a rain gauge to measure the amount of rainfall. So rain gauge is used to measure the amount of rainfall. So let's look at how a rain gauge looks like. Now, a rain gauge is actually made up of 4 basic components. It's made up of an outer jar or cylinder. An outer jar or cylinder is made up of an inner copper jar. So we have 2 jars. We have the outer jar made from from copper, and the inner jar also made from copper. So the outer jar will be immersed into the ground, while the inner jar will contain the metal funnel that has a radius of about 12 to 20 centimeter, radius of 6 to 10 centimeter, or a diameter of 12 to 20 centimeter. And then we also have a glass bottle that is usually calibrated. Now, what we do is that this rain gauge is being taken out to an open space, not in a building, to an open space where the amount of rainfall can be collected and measured. So let's look at how we can use this rain gauge. So one thing is that when you keep the rain gauge outside there in the on the open space, possibly a field, the thing is that rainwater will enter that rain gauge through the funnel, So first rain will enter through the funnel, and when that happens, after the rain has stopped, you take the funnel and you read the measurements on the calibrated glass bottle, and it's usually calibrated in millimeters, So once you get the millimeter of rainfall for that day, you record it on the recording sheet, you throw the water away, and you do it the following day continuously for the month. Now the average value of rainfall collected for that month will give the average monthly rainfall. And when it's done continuously for the 12 months of the year, the average rainfall, is actually the average of each month, combined together to give us the average annual rainfall. So this is a typical illustration of what a rain gauge looks like. So we have the outer cylinder and the inner cylinder. Then we have the funnel that is 12 to 20 centimeter in diameter, and then the rain gauge is kept 30 cm away from the ground. This is actually to prevent a splash or irregularity in the amount of rainfall being measured. So when the rain is over, we pick up this rain gauge and we read the value of this calibrated glass bottle or the calibrated inner cylinder. So the value of the water droplets will give us the amount of rainfall for that day. So what are the precautions we must take when using the rain gauge? Now, the first precaution is that you should keep it in an open space. Don't keep it close to a building so that you will get an accurate result, because keeping it close to a building will cause water splashing, or will cause irregularity in the amount of rainfall being measured for that day. And also, when burying the rain gauge in the ground, ensure that it is 30 cm above the ground level, so that water will not splash into the rain gauge. Now we do all this to get a degree of accuracy, when determining the volume of rain for that day. And also, the outer jar, is to be veiled, or is meant to slope, so that the raindrops can easily silt inside. And water is only made to enter the rain gauge through the funnel. So you ensure that you always have a funnel fitted in the rain gauge, because if there is no funnel, there will be There will be a poor value, of rainfall that will be measured for that day. So you ensure the funnel is there, and the funnel is 30 cm above the ground level, and water should only enter the rain gauge through the funnel. So how can we calculate rainfall data? To calculate rainfall data, we must take note of mathematical values like annual rainfall, the mean annual rainfall, and the mean monthly rainfall. When we talk about the annual rainfall, we're talking about the total amount of rainfall from January to December. So you add the rainfall for all the 3 months. But if you are talking about the mean annual rainfall, we calculate the average of rainfall for the 12 months of the year from January to December. And for the mean monthly annual rainfall, we take note of the rainfall for the number of days in that particular month, and we divide them by by the total number of days to get the mean annual rainfall. So now let's take a question on how we can calculate the annual rainfall and mean annual rainfall. So as we have here, this is a table showing the rainfall from January, February, March down to December. So they say use the data in the table above to calculate the following. First, we calculate the annual rainfall. Second, we calculate the annual range of rainfall. And third, we calculate the mean annual rainfall. Like I said, to get the annual rainfall, what do? We add the value of what? Of rainfall from January to December. So annual rainfall will be equal to 40 plus 50 plus 136 plus 228 plus 274 plus 370 plus 391 plus 303 plus 434 plus 323 plus 112 and plus what? Plus 29. So to get the annual rainfall, we simply what? Add the rainfall of January, February, March, April, May, June, July, August, September, October, November, and December. And that will give us what? The annual rainfall for the year. But if they say number 2, it says calculate the annual range of rainfall. Range means the highest minus what? The lowest. So if you look at the table, the highest rainfall is in the month of what? September, which is 434 what? Millimeters. Then the least rainfall occurred in what? In December. So the annual range will be what? 434 minus what? 29, which is going to give us what? 405 millimeter. So that is the annual range of rainfall. Then the third question says, what is the mean annual rainfall? Mean means total over number of what? Number of occurrence. Now, if you look at the mean, the table, to get the mean annual rainfall, you simply what? Get the value of the sum of all the rainfall from January to what? To December. Now, when you get the value, let's say the value is X, you divide it by what? By the number of months. So we have 12 months in a year. So the total annual rainfall divided by 12, and that will give us what? The mean annual what? Rainfall. So to get the mean annual rainfall, add the amount of rainfall from January down to December. You add them all together and divide it by 12, because we have what? 12 months in a year. So when you divide the total rainfall by 12, you will get what? The mean annual rainfall. Now, let's look at the next one, which is what? Which is called what? Temperature. Now, temperature is simply what? The degree of hotness or coldness of a place or a thing. The degree of what? Hotness or coldness of a place or of a thing. So it simply tells us how hot a thing is or how cold a thing is. And the instrument we use for measuring temperature is called a thermometer. So the thermometer, as you can see here, it contains a thermometric liquid, and we use it to what? To measure what? The degree of hotness or coldness of a particular body. So now let's look at how a thermometer looks like. If you look at this now, it consists of a narrow glass tube. Now, this glass tube is calibrated in such a way that it fits the liquid in it. And this liquid in every thermometer is called a thermometric liquid. Now, the two major thermometric liquids that are found in thermometers all over the world include alcohol and what? And mercury. And why they actually call it thermometric liquid is that they respond to changes in the what? In the temperature of the environment. So whenever the environment is hot, some tend to rise, some tend to what? Fall. So with these changes or responsive nature of this liquid, they actually make use of them to what? To construct thermometers. So as you can see here, this is a thermometer, and this is the what? The thermometric what? Liquid, and they change with what? With a change in what? Temperature. And so as a result of that, we can actually use their changes to what? To dictate the what? The temperature of our body, or the temperature of a particular what? Thing. So we have different types of thermometer. We have the dry bulb thermometer, and we have the wet bulb thermometer, and we also have the maximum and the minimum what? Thermometer, or you can call it the sixth thermometer. Now the dry bulb and the wet bulb thermometer are actually used to construct what we call a hygrometer. A hygrometer is used to measure the humidity of a particular place. As you can see, this is a typical example of a hygrometer, and the hygrometer is made up of what? Two different what? Thermometers, which is the dry bulb thermometer and the what? And the wet bulb what? Thermometer. So with this combined together and other features, they can what? Construct what we call what? A hygrometer that can be used for measuring the humidity of a place. And then we look at the second type of thermometer called the maximum and the minimum what? Thermometer. Now the maximum thermometer is combined with the minimum thermometer to form what we call the sixth thermometer. Like I said, the wet and dry is combined to form the hygrometer. Then the maximum and minimum is combined to form the what? The sixth thermometer. And we're going to look at how the sixth thermometer looks like. Now the sixth thermometer is in form of a U shape. There is a U-shaped glass tube which has the maximum on one side and the minimum on the other side. So the right hand side of the thermometer measures the highest temperature, while the left hand side measures the lowest temperature. That is the maximum temperature and the minimum what? Temperature of the day. So as you can see, this is a typical example of what the sixth thermometer is. So it's made up of the right hand side and the left hand side. So this side will measure the maximum temperature ranging from 0 down to 40 and above, and this other side will measure the what? The minimum what? Temperature ranging from 0 to what? To minus 25 and lesser than that. And in the maximum and minimum thermometer, we actually have two thermometric substances in it, and these two thermometric substances, they respond to an increase in temperature, and also to they respond to what? A decrease in temperature. So as a result of that, we can use them to what? To measure the what? Measure a high temperature value and a low temperature what? Value. So what are the working principles of a thermometer? Now the thing is that thermometers containing alcohol, mercury, they expand when you heat them, and they contract when the temperature is very low. That is when they are what? Cooled. So with this, whenever there is a slight increase in temperature, you see that the mercury or the alcohol there in the thermometer will gladly rise above what? Above the initial level in the tube. So as a result of that, we can easily take what? Measurements when the temperature of a place is very what? High. And the reverse is the case. So using this principle, we can easily calibrate a thermometer to detect the temperature what? Change in what? In the environment. So they work based on the principle of what? Of expansion and what? And contraction. So let's look at temperature scale. Now we actually measure the temperature using what? Using different scales, and the scales that we use predominantly includes the Celsius or the centigrade scale. We also make use of the Fahrenheit scale, and we also make use of the Kelvin scale. Now we also have the Reaumur scale, which is an obsolete type of scale that is not actually used in the present day. So we're going to look at how we can use the Celsius scale, and also how we can use the Fahrenheit scale, and how we can use the Kelvin what scale. So let's look at how we can use them. Now, we can actually convert from one scale to the other. We can convert from Celsius to Fahrenheit, from Fahrenheit to Celsius. We can also convert from Celsius to Kelvin, or from Kelvin back to what? To Celsius. So let's look at the formulas that we use. To convert from Celsius to Fahrenheit, we simply what? Use this formula, which is 9/5 times what? Times the Celsius value. Then the answer, we add it to what? To 32. Then to convert from Fahrenheit back to Celsius, we simply do 5/9 times whatsoever we get from the difference between the Fahrenheit value and what? 32. Then for Celsius to Kelvin, we simply do the degree Celsius plus 273. Then to convert back to Celsius, we do the reverse. We simply say the Kelvin value minus what? Minus 273. So let's quickly look at some examples. Now the first one says convert 200 degree Fahrenheit to what? To Celsius. Now we have what? 200 degree what? Fahrenheit to what? To degree Celsius. So we make use of the formula 5/9 degree what? Degree Fahrenheit minus 32. So this is the formula we use whenever we are converting from Fahrenheit to what? To Celsius. Now, what is the value of degree F? 200. So we simply what? Put in that value right here. So it will be 5/9 into 200 minus what? 32. So 200 minus 32 will give us what? This is 8. This is 6. 168. So we have 5/9 times 168/1. So when you continue further, the answer will be in what? In degree Celsius. So that's how we can what? We can easily convert. So if you take 9 here, 9 goes here, 1 remainder 7. 9 goes into 78 is 8, 9, 72. So it's 8 remainder 6/9. So 5 times 18, 6/9 will give us the resulting answer. So let's quickly look at the reverse of the case. Let's have a scenario where we are converting 200 degrees Celsius to Fahrenheit. Let's say we are converting from Celsius to what? To Fahrenheit. So we use the other word formula, which says 9/5 times degree Celsius plus what? Plus 32. So we put in the 200 Celsius down here, and we add it with 32. So we have 9/5 times 200/1. Then the answer, we add it to what? To 32. So 5 here, 1, 5 here is what? 40. So 9 times 40 is about 360 plus what? 32. So when you add that, you will definitely get what? A 392 degree what? Fahrenheit. So this is how you can as well what? Convert from what? From Celsius to Fahrenheit. Then the third question says we should convert 400 Kelvin to what? To degree Celsius. Now, in order to do that, we make use of 273. So to convert from Kelvin to Celsius, we simply do what? K minus what? Minus 273. So Celsius will be what? 400 minus what? 273. We have 273 here. This is 723. 127 degree what? Celsius. So what you simply need to do is that from Kelvin to Celsius, you subtract. So you see that a 400 Kelvin will give us what? 127 degree Celsius. And the last we have is to convert 120 degrees Celsius to what? To Kelvin. So if we want to convert 120 degrees Celsius to Kelvin, what we simply need to do is that we have that Kelvin is equals to what? Degrees Celsius plus what? Plus 273. So we put in the value of Celsius here, which is 120 plus what? Plus 273. So when you add this, you're going to have what? 300 and what? And 93 what? Kelvin. So it means that 120 degrees Celsius converted to Kelvin will give us what? 300 and what? And 93 Kelvin. So this is how we can actually what? Convert from one temperature scale to what? To another temperature what? Scale. So let's quickly go straight into the ExamGuide app and look at some questions. So we start with, let's go to the SSCE to be precise. Okay, so this is the ExamGuide app, and we are going to look at 2010. Let's go to 2010. Now this is 2010 Geography Theory 1. And then we look for question number 3. Now, question number 3 says, with the aid of a label diagram, describe the instrument used for measuring rainfall. So, all they simply need you to do is that in this space given, you should what? Draw the rain gauge. So they want you to draw an accurate diagram of the rain gauge showing the inner cylinder and the outer cylinder with the measuring funnel and the dimensions and how you can, place it in the ground and take your what? Your accurate measurement. And they say explain, the second question says explain how the instruments are used to obtain the annual total what? Rain. So previously we've talked about this. What you simply need to get the annual total rain is that you take the measurement, the rainfall for each day, after the first day, once the rain is over, you take the reading in the recording sheet and you pour it out. You do the same for the next day till the end of the month, and you calculate for what? For that month. Now, when you calculate the total rainfall for the 30 days, total rainfall for the past 30 days, you will get the what? The monthly total rainfall. Then you do that continuously for the remaining what? 12 months. Now, the monthly rainfall for January plus the monthly rainfall for February, March, April, down to December. When you add them together, it will what? It will give you the annual total what? Rainfall. So that is how you can use that instrument, to get the annual rainfall for any given what? Year. So they say state any 2 precautions to be taken in the use of the instrument. So like I said, whenever you're using the rain gauge, you should ensure that water or rain gets into what? Into the rain gauge through the funnel only. And also ensure that the funnel is 30 centimeters from the ground level to avoid water splashing. And when you're putting the rain gauge in the ground, make sure that the rain gauge, the external container, is also 30 meters. Part of it is 30 meters from the ground level, so that water will not splash in it. So these are some of the precautions you can take when using the rain gauge. Thank you for participating in today's class. You can practice more questions using the ExamGuide app. The app scores and gives a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that make learning fun. It's a must-have for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel, hit the notification bell, and share the videos to people that will benefit from it. Bye.